Hello and welcome to this webinar around integrating on-premises vendors with AWS for backup. My name is Isaiah Weiner. I am a Senior Manager of Solutions Architecture in the partner team at AWS. And today we're going to talk about that much loved topic of backup. Now, backup isn't just another copy of your data, although sometimes that's sufficient for some applications. If you talk with backup administrators, they'll tell you that there's several properties that distinguish a backup from simply another copy of the data or from an archive. Backup is point-in-time consistent, and it's point-in-time consistent not only at the time of copying the data out, but also at the time of doing the restore or the recovery. A proper backup is indexed and searchable so that you can apply policies around retention. Retention for backups is often short-term. It's really common to see customers and large organizations retain data for as little as 30 days, sometimes 45 or even 90 days. And sometimes that rotational element is on a schedule. So for example, you may have hourly backups of some server resource or storage resource. And then at the end of your retention for those hourly backups, you might roll it into a daily backup, and then you might keep that for a while and roll that into a weekly and roll that into a monthly, et cetera, and so on. And so it's really common with all of those coexisting schedules to have many copies of the data. In fact, I've seen customers have as many as 50 to 100 copies of the same piece of data. And so technology in your backup infrastructure around things like deduplication becomes really important. And deduplication is often powered by the index. So the index is super important. Another element that's very important in the backup world is reporting and being able to be accountable for auditing purposes, being able to say yes with 100% certainty a resource was protected, even if you didn't necessarily have authority over that resource. That's a very common requirement that backup administrators receive. Please protect these things even though you're not managing them. Now, how does that differ from archive? Archive is often simply one copy of the data, not 50, not 100. And archive is often managed by business units as opposed to maybe storage administrators. And so when I say business units, I mean if you look at the applications that are used for archival purposes, whether it's email messages or official documents, the policies and the people who are managing these things are often more in line with what we call lines of business or business units, rather than simply being part of maybe a storage team. And when you look at archive, it's often not short-term retention, it's often long-term retention. And so when you look at the pricing and the semantics around how you utilize archival services, they're also built toward long-term retention. You know, for example, Glacier pricing and the way that Glacier retrieves things is built towards long-term retention. And then lastly, archive is often associated with compliance. So if you have any SEC requirements or if you have any maybe HIPAA requirements, all of these compliance-oriented workloads require that you not only archive the data for a long time, but also protect it. So backup and recovery before the cloud kind of looked like this. And you know, if you've spent any time in a backup environment, this should look very familiar to you. You know, your tapes going into a truck and going down the road to a data bunker somewhere like an Iron Mountain type service, and then anything that you needed to be able to retrieve is going to live on local disk. So there's two problems with this. The first problem is that that local disk is in usually the same facilities as the rest of your applications and your servers, which means that you've got some blast radius elements to be concerned about. And then the second problem is that that second tier of the backup, not archive, backup, is going into a truck that is driven by somebody who doesn't frankly care about your tapes. At this last reInvent, we had a chalk talk about backup and recovery architectures, and we were asking for, you know, what are some of the crazy stories that people have accumulated over the years. And one gentleman raised his hand and he said, you know, I was doing a tape recall test to see you know, what our RTO was going to be and how easy it was for us to restore from our tapes. And the truck carrying the tape caught on fire. And there goes your tape. So if that was your only copy of that tape, that's not good. If something that you needed to restore from that tape was in that truck that caught on fire, you're not gonna have access to that data anymore. So we want to get away from that, not only for the first tier of being able to make sure that that locally retained data is protected, but still be able to service user requests, customer requests internally, but also so that that longer term tier of backup, not quite archive yet, still backup, is protected from scenarios where human beings or scenarios outside of your control might impact it. So with the cloud, a couple things change. First of all, when applications first started writing to the cloud, they didn't do it on their own. They usually use some sort of gateway device, and we'll talk extensively about gateway backup strategies. For applications that are file-oriented or that are block-oriented, the concept of using a gateway makes total sense. It's really the easiest way to go. There's like zero overhead associated with swapping out an existing solution and putting in something like the Amazon storage gateway. And when you look at the applications that have been built since then, since those gateways became popular, a lot of them have native cloud connectors. And so it's really common today to use backup applications on-prem that already support the cloud. In fact, you may be using an application today for your backup solution that turning on support for the cloud is as easy as checking a box or creating a cloud disk pool, giving it some credentials, creating a bucket, and away you go. It's really not difficult. And we'll talk about the applications that support that soon. So today we're going to talk about various elements of the AWS storage portfolio. If you don't know what the things are on this slide, I'll just briefly go over them. Amazon S3 is probably the Swiss Army knife of cloud storage. Its semantics are very simple. It is object storage, and you might ask the question, well, what's object storage? How is that different from a file or a block? Well, the differences are really in what you do with things. So, with a file, you can append to it, or you can, seek to the middle of the file, rewrite a few blocks, and the latency is pretty reasonable. It's not hundreds of milliseconds. It's usually single digits or double digits of milliseconds. With block storage, there's no abstraction, whatsoever. It's just raw. Applications like databases tend to use it, or operating systems, or if you have a file system that needs a block device, you use things like Amazon EBS. For people who have on-prem backup solutions that are writing to the cloud, what they really need is they need semantics that are going to allow them to easily put data in, easily get data out, and not have to rely on any sort of single point of failure or bottleneck. So you need something that's going to scale really well horizontally. And so Amazon S3 is the answer to that. And then for things that are accessed maybe less frequently, we have additional storage tiers like infrequent access. We have our new one zone as well. And for long-term archival, things like Amazon Glacier. But the gist of it is that Amazon S3 as an object store was designed for bursty workloads. And so what that means is that very busy web properties use it to serve content, backup applications. Ingesting a bunch of data that's been changed in the last backup window is right up its alley. So it's a very, very good fit. Other things that we'll talk about today is our Snow family of solutions. We'll briefly touch on AWS Direct Connect as a way to get data from your on-premises environment into the cloud. And Storage Gateway, we'll talk about all the different deployment models. And then lastly, we'll talk about partner connectors. So that's what we're going to be talking about today as it relates to AWS. And we'll talk about some partner solutions as well. So all the logos that you see here are solutions that have been custom integrated with Amazon to make the customer experience great. And that was the goal from the very beginning of a lot of these partners when they started down their path to the cloud. And if you were to sort of rewind the clock, a couple of years, 2 or 3 years, there would be one or two icons here. There really wouldn't be the dozen or so icons that you see. And so that means two things for you as a customer. The first thing is that your options and your ability to have choices are always getting better. It's a much richer community of partners today than it was a handful of years ago. And two, because there's more competition, for consumer dollars, but also for consumer eyes and consumer sort of install base, right? There's drag associated with a lot of these workloads. When you choose to back up to the cloud, a lot of times you choose to do your restores into the cloud as well, or your restore testing. You don't necessarily always do your restore on-prem, and so these companies realize that. These are our technology partners. We have very great relationships with a lot of them. Many of them have been launch partners for new services, and they're all looking to beat each other to the punch to get your attention because you're the customer. And at the end of the day, for us at Amazon, it's all about customer obsession, and for our partners, they embrace that as well. When we talk about backup and recovery, we will be using language like reference architectures. And so here's a very common reference architecture. And so, if you think about the left-hand side of the screen is your environment, you've got your, all your assets that you're trying to protect. And then the right-hand side of the screen are the services that you might be talking to. In a very typical example, your backup solution might, even an incumbent backup solution might support AWS already, or if it doesn't, then we have our storage gateway, and it's a very sort of plug and play way to interact with the cloud. And so if you ask yourself, okay, well, what for storage gateway, where would I put it, right? You can see it's right there in the center. And I will just draw it for you here with my, or I'll use my laser pointer. Right here is the storage gateway. That's where it lives. And so if you happen to have an older version of a backup solution that maybe doesn't have a native cloud connector, then what you probably have is you have something that can write to a file system or write to a block device or would understand the VTL protocol, the virtual tape library protocol. Virtually everything understands that these days. And so you've got at least 3 great ways, even outside of the cloud connector, to get your data up into AWS. So without any further ado, we will move forward. So as I mentioned at the beginning, there were cloud gateways, and cloud gateways are, for the most part, things that should be fairly low overhead. So we've got, in this slide, we've sort of got 2 options. We've got, a partner solution here, and we've got our AWS storage gateway. The AWS storage gateway is fantastic, and it's super cheap. There's really not any real reason to not use it. It's got a bunch of different deployment methodologies. So the first deployment methodology is the file gateway. And so what that means is that you install on premises. You can do it in EC2 too, but today we're talking about on-prem. You install a virtual machine, and that virtual machine is going to present an NFS export to your clients. And data that you write into the file gateway is then going to be translated semantically from file to object. And for 99% of the customer escalations that I see, when people say, I need a cloud gateway and I have an application that writes files, and when I put the data in S3, I need it to look exactly the way it looked on the file system. AWS Storage Gateway is for you. In 99% of the cases, it will fit everybody's requirements. If you have file-based workloads that an application cannot be refactored for object purposes, or if you maybe it's just not a priority, maybe you don't want to refactor it, File Gateway can solve that problem for you. And so you might ask the question, well, what happens with things like CH mods or appends or all these things that like S3 doesn't natively support? I'll talk about that. For the next one, it's Tape Gateway, so VTL. With VTL, it's a form of iSCSI, so it has all the good things that iSCSI has around things like MPIO and retry capability, but it's also got all the great things that tape concepts have, like the tape, maybe isn't there because you don't have access to the internet, so your application doesn't go bonkers, or you want it to slow down and not send data as fast. All of these kinds of things existed in the tape world for literally decades, and by using VTL, you don't have to change your model at all. It's a great way to get data into the cloud. Basically, you get a virtual tape concept on a virtual library, a virtual shelf. You can pretty much have an unlimited number of virtual tapes. And when you write your data into S3, that's your hot tape. And when you want to archive it, you literally click a button and it goes right to Glacier. So it couldn't be simpler. It's fantastic. And then we have the block version of the gateway, what we call the volume gateway. And it was the first, actually, the first, AWS storage gateway sort of implementation. And it's gotten really great over the years with customer feedback. We've built in sort of a consolidated deployment model. You don't really have to choose between, a cache gateway or uncached. You're not talking directly to S3, you're actually talking to a service. And what that lets you do is it lets you do things like say, I want to take a snapshot of what's on my gateway. So I might have a volume, an iSCSI volume that I'm presenting to my backup server, or even just to an application server for that matter, and you want to take a snapshot. So maybe you've quiesced the data on the volume, you take a snapshot, and then that snapshot is now available as an EBS snapshot. So there's a lot of power there, because what it really lets you do is it lets you go from directly on-prem to directly into the cloud in a way that would then let your application use the data exactly as it was on-prem. So when you look at all three of those deployment methods, it's rare to find something that doesn't fit for somebody. More often than not, people maybe if they got started with Gateway a while back, maybe a couple of years ago, they're using iSCSI. But like I mentioned when I started talking about File Gateway, for the vast majority of cases, File Gateway is fantastic for people. It is NFS only, so if you have a Windows requirement, one thing you can do is you can run the NFS client that some newer versions of Windows have, but you can also, frankly, you could just put an NTFS file system down on that iSCSI volume and re-export it as SMB. That's a good solution that a lot of customers use as well. So I mentioned that I would talk about sort of the semantics element of File Gateway. So if you were to do something like a chmod in a file system, you're just changing an inode flag to say that this field of an inode is going to be updated with this new value. There isn't really a way to do that inside of S3. So what the File Gateway does is it has a set of behavior mappings internally, where it is clever about keeping the right data cached for you and managing what's called a write-back cache. And so if you changed, maybe you renamed the file, or you changed, a mode on the file, or an owner, or something like that, File Gateway is actually going to create a new version of that object. But it doesn't necessarily have to re-upload if you haven't actually changed the content. So it's very clever about saving your bandwidth while still preserving the format of your data. Now, a lot of people will use third-party products and they write the data to S3, and then they go back and they look at the data and they're like, I can't use this data because it's all opaque. Maybe the files got normalized into uniform object sizes, or possibly there's even something else going on there that makes it impossible to read. And so File Gateway operates on this principle of do not molest customer data. Everything that you write into File Gateway goes directly into S3. And you can still use lifecycle policies to manage the storage tier for that data, but File Gateway is designed so that when you're on your journey to the cloud, whether it's via an application that you're migrating or taking backups, you still want to be able to do stuff with them. So if you have backup data that you're putting into File Gateway and it ends up in S3, you ought to be able to use other services on that, whether it means you use Redshift or EMR or run an application that's then going to go read that data and represent it, or if you want to distribute it with other services like CloudFront. All of these things are possible when you keep the data in its original format. And so File Gateway stays true to that idea, and it's certainly, it may not be a surprise to you, but it is the most cloudy of the cloud gateways, allowing you to natively take advantage of the most services. So things like append are going to be copy plus puts with versioning on the object. So if you had an application maybe that was writing data out to a file in a buffered way, maybe it would let a megabyte or something go into the buffer, and then it would write it out to the file system. The file gateway would do a copy plus a put on the object, and the new object would be the old version of the object plus that 1 megabyte buffer. And you could see that accumulation of data. If you were appending data to a file on the file gateway, you could see that in the different versions of the object. And so understanding how these things operate is important, because file gateway, well, it's not 100% perfect. It's like 99% perfect. And so if you had a very large file that you were creating, or if you needed to do things like log rotation, or if you had backups of maybe database dumps, these are all things that you're going to want to be able to know for sure have been written and the integrity of them is correct, what you expected, right? So the integrity being what you expect, file gateway is a great place because of its cache to do things like do checksums, and then you can compare that against the e-tag on the object. So if you have some sort of automated internal system in your own operations for how to verify that your backups are good, it would integrate well with file gateway as well. So it's just a great, in much the same way that S3 is a Swiss Army knife of object storage, file gateway is very much a Swiss Army knife for cloud gateways. I mentioned before also that the volume gateway, because it's presenting an iSCSI volume, your application server, whether that's a piece of backup infrastructure or an application itself, is going to be able to write to it as if it's just a normal block. And so this virtual machine that you install on-prem, you present to it this iSCSI volume, and performance is going to be whatever the underlying storage that you've provisioned for the volume gateway is. So if that happens to be flash, then you'll get flash-like performance. If it happens to be disk, you'll get disk-like performance. But regardless of what kind of media you put underneath it, you still get the ability to do things like take EBS snapshots from the on-premises volumes. And then you also get the ability to create on-premises volumes from EBS snapshots. So let me give you an example about maybe a scenario where you might do that. Let's say, for the sake of argument, that you moved a workload into the cloud and you decided that you didn't want it to be there anymore. How would you move it back on-prem? Well, there's a couple different ways to do this, but one easy way to do it would be to simply take a snapshot of the EC2 instance's EBS volume. Now that you have that EBS snapshot, you can create an on-premise volume in Volume Gateway from that snapshot. So it's like a two-way street. You can move data directly from on-prem into the cloud, and you can also move data from the cloud directly onto on-prem, using a consistent set of tools, and using, frankly, using console, right? Using the native Amazon tools, so it becomes very intuitive. And Tape Gateway, just to reiterate, it's supported by practically everything. So if you've got an application today, a backup application today that knew how to talk tape in the past, chances are pretty good that it knows how to talk BTL. Not every version of every piece of software works. If you have a 14-year-old version of something that you haven't upgraded, it's possible that you might need to do 1 or 2 updates. The reason I mention that is it's totally normal to see backup applications not get upgraded because you don't necessarily have a reason to. There's not necessarily any new features. And I would argue that keeping your tapes out of trucks that can catch on fire is a great reason to update your backup infrastructure, at least to the point where you can talk VTL to the storage gateway in tape mode. And if you want to upgrade it even further, then to the cloud connector. So and then lastly, just to reiterate, the Tape Gateway is really, it doesn't get any simpler. You're not changing radically the model for your backups. You can still do things like search by job ID. If you use traditional tape labels, you can search by tape label as well, and most of backup applications index that data as well. If you have standard operating procedure books that refer to tapes, Nothing changes here. The only difference is that in the context of a tape where it used to be physical, it's now virtual, and you have to add a sheet to your standard operating procedure book about how Tape Gateway works, and if you have a virtualized environment, there isn't really any additional hardware to procure either, because Tape Gateway is super low overhead. So when you do your deployment of AWS Gateway, Storage Gateway, you should think about, what are the modes that you want to operate in, what's possible today. And if you look at the Storage Gateway documentation, you'll also find a matrix of backup applications and versions that have been tested and are known to work with the VTL mode of the Storage Gateway. Pretty awesome. Another thing that we talk about with backups, especially going from on-prem to the cloud, is the concept of seeding. And so if you don't know what that is, a lot of times people will invest in all kinds of hardware, but they won't necessarily invest in their network. Also very normal for networks to sort of be forgotten. As long as everything works, nobody thinks about it. And then when you have capacity issues, you upgrade components. You may not upgrade everything, but you might upgrade a border router here or a core switch there. One of the things that people often don't upgrade until they absolutely have to is their transit connectivity, or your ISP, in other words. And the reason people don't do it is because it locks them into long-term contracts. And so if you haven't heard of Snowball, this is a great way to avoid having to re-up your internet service provider and get committed to a contract that maybe you don't really need. If you have a bunch of data that you've already got on-prem that you want to send to the cloud, but your net new data on a weekly basis actually maybe could be handled by your existing internet service provider and your existing transit bandwidth, then you don't necessarily need to get a new contract. What you really need is a device that you can offload that data to and then physically mail it to Amazon and have all that data magically show up inside of S3. So today you can use Storage Gateway in a file-oriented mode. You can use it in an object-oriented mode. An object-oriented meaning it presents an S3 interface, so you can use things like the AWS CLI tools to copy data onto it. The Snowball Edge presents NFS, so you can use an NFS client. You could, with the original Snowball, you can use the original CLI tools to copy file-based workloads onto the Snowball device, and you basically you get this thing in the mail. It looks just like what it does on the screen. I say in the mail; it's a package delivery. It's got like a Kindle shipping label on it, and when you power cycle it, it'll swap the ship to and return addresses. And so when you're done with it, after it's full, you just, or it doesn't even have to be full, but when you're ready to send it back, you shut it down, and that e-ink shipping label updates, and it's going to go back to Amazon, where it will be uploaded to S3. Now, two awesome things about Snowball that a lot of people maybe don't think about. So the first thing is, after you put your data on it, you do not necessarily want to delete that data that you just copied to it, because something horrible could happen to the truck that it's in. As we talked about at the beginning, things happen to trucks. Now, you can rely on this in moist environments, lots of rain, or snow or sleet, or hail, these kinds of things. Due to the ruggedized exterior, it's fairly water resistant. It's got a crazy amount of impact force protection inside of it. You can perhaps read about on the internet, if you were so inclined, people, I'm not advocating this, just to be clear, people throwing it from places that are fairly high, and it's surviving and being just fine. One of the things that we actually do on the floor of our Amazon Summit series and reInvent is in the booths where we have these Snowball devices. We let people, throw them up in the air, and they can see how they hit the ground, and they're just fine. These are really rugged devices. They were designed, purpose-built. The PC inside is commodity. There's a lot of great technology in there, but the exterior was really designed for not ever needing to, put something in a box. So it arrives on your loading dock. You flip the access to power open and access to network, It comes with SFP plus slots, so pretty much any media can be supported. And with all of those file-based interactions or object-based interactions, it supports a lot of applications out of the box. So AWS CLI tools, which I mentioned, and the native NFS export. If you're using a backup application, a lot of times since this is going to end up as an object, a lot of times the formats that backup applications use for objects and backup applications use for files are a little different. And so when you upload it, if you were to just copy the backup files from, let's say, COMMVAULT, for example, into this NFS share, COMMVAULT would have a hard time with that. When it ended up in S3. So what COMMVAULT does instead is they actually use their native S3 connector, and they've got documentation on their website about how to do this. They actually talk to the Snowball device the way they would talk to S3. And so that allows them to write the data there in a format that is what it's going to expect when it gets up to S3, and then reconcile the location change in the catalog. So step one is you get your Snowball, you order it off the console. Step two, you configure COMMVAULT to create a cloud disk library that points directly to the Snowball, and then when the auxiliary copy is done, you ship it back. When it shows up in S3, COMMVAULT can reconcile those two locations and update their catalog, and then you can delete the copy that you had on-prem. So you fill up the Snowball, and you can do this, by the way, in parallel. You don't have to just order one and then wait for it to go back and then order another. You can absolutely order multiple. Snowball Edge actually has a clustering mode, so you can order, let's say, 5 at a time, and you can have a cluster of 5 units, give you fantastic aggregate throughput and a lot of capacity, because I mean these things are big, right? Think 100 terabytes, kind of big, and since you don't have to buy it, you're only paying it for it. It's referred to as an order, right? So you've got the time basically that it's on-prem, and you have a certain amount of time that's built into the cost of the order, and then if you want to keep it for longer, you just have an overage charge that applies. And we don't include the time when it's in transit against the time for when you have to copy it. So if you compare the cost of a Snowball order in the $200 range with the cost of maybe upgrading your internet service provider to give you a gig plus or 10 gig connection for the next, let's say, 3 years, it's kind of a no-brainer. So if you have a lot of data on-prem that you sort of have sitting around and you think, well, gosh, I'd like to put that in the cloud, but I don't know how, please consider Snowball seeding as an ingest methodology. So now we're going to talk about some partner solutions, and we're also going to talk about customers. So when we talk with our backup partners, a lot of times we try to frame things in what we call reference architectures. So, I had an architecture earlier up that sort of showed you, left hand on-prem, right hand in the cloud. This is very, very similar to that. And so all of the partners on the right, that list, that's a very long list of partners, support this architecture. And so this is the simplest, most low-hanging fruit architecture for backing up data to the cloud. It is exactly what we've talked about so far. It is using AWS Storage Gateway as an intermediary, or using a native cloud connector to talk directly to S3. And if you're using anything in the list of solution providers on the right, chances are you already have the ability to do it. The second reference architecture is a little bit different. So the main difference is where your point of control is over the backup infrastructure. So you can still be backing up resources on-prem, but you could have your, let's say, point of control for your backup infrastructure located inside of AWS. So why would you do this? Well, one of the reasons that people do this is they like the idea that should they actually have a customer side data center failure, that they wouldn't necessarily have to worry about having to reinstantiate their backup infrastructure before they were able to do restores. And that's a very valid point. One of the things that people discuss when they talk about what their RTO is going to be able to be is that there's this assumption that your backup infrastructure is already there. So when you think about your restores, and this is sort of bleeding the line between backup and restore and disaster recovery, but when you think about the restores that you're going to have to make, if you have to make a lot of them all at once do you need more backup infrastructure? Do you need more media servers? You know, in most backup infrastructure environments, there's this concept of a media server, and things like VERITAS NetBACKUP and COMMVAULT scale out horizontally on the media server side, or media agent in one of their parlance. And you know, it doesn't take that many of them to push a lot of aggregate throughput for a restore or for backup, but if you're trying to restore a lot of data all at once, you could be in this situation where you say, okay, I don't have enough of them. What's my overhead associated with bringing up a new one? If you're in a virtualized environment where you have templating, it might actually not be that much, you know. But if you're not, it could be a little while. And so having your infrastructure able to be sort of, you know, spun up on a moment's notice inside of AWS from a backup perspective gives you the ability to then restore. And you can use, by the way, Snowball to do the restore in addition to using Direct Connect or your internet connection. And you wouldn't have to worry about losing your master server on-prem, and you wouldn't have to prioritize restoring your master server on-prem at the point that you're doing the restore. So so this second architecture is sufficiently different to warrant its own slide, I think. But the nuance is there for backup people. So if your role is not necessarily backup admin, but you might just be sort of in charge of storage generally, or you might be you know, spearheading this movement to move your backups to the cloud, that subtlety is worth investigating whether or not you want to go do that. And then the third one is an infrastructureless component. And so when I say infrastructureless, what I really mean is backup and recovery as a service. So there's a lot of people out there, a lot of third parties that claim to have backup and recovery as a service, and they might have it. You know, they might you know, have an agent that you download, or an agentless approach that if you have a virtualized environment where it's talking to the hypervisor systems on all of your virtualized servers, and writing data back to maybe a managed service. So the difference between that kind of thing and what I'm talking about is, where does the data end up, and how well can it respond to customer demand? So as far as I know, and I've been in the AWS partner organization for over 3 years, there is only one solution provider who does backup and recovery as a service and is built on AWS and has architected their service not simply in a way where they have an on-prem component where they're just running it in EC2. They've actually architected their service for the cloud. You know, if you were thinking about the backup workload and you thought about, well, there's metadata and there's data, and then there's going to be features that I'm going to need to nail down around that, you know, searchability and how do I manage encryption keys, and you know, how do I manage users, and how do I enable self-service? All of these kinds of things are important to backup administrators. And if you were going to build that using all the Amazon best practices, all the AWS best practices, it would look like the DRUVA service. You know, they heavily use DynamoDB for their metadata element. They use S3 for their data element, and they've got some support for a lot of different front-end platforms. So they have sort of two, well, we'll talk about their solutions a little bit later, but they've got their sort of, you know, laptop and desktop products, but then they've also got their you know, server virtualization products as well. And so you get, in addition to backup and recovery services, you get other stuff because your data is already there. You get, you know, all the legal search and hold stuff. You get, you know, the ability to create policies and deploy them to everybody at once. You get the ability for users to do self-service and even upgrade. Right? You got an old laptop, you got a new laptop. You take a backup on one, you do a restore on the other. You don't just get your data, you get all the metadata components as well, like accessibility features and, you know, what printers are installed. Like, it's really soup to nuts. It covers everything. But you also get things like, you know, file sharing, like sync and share. You know, think of it like a Dropbox type thing built into the service. And on the server side stuff, you get not just the backup, but you also get like a DR solution related to failover. So so these these architectures sort of are fundamental, foundational to the use cases that when we say backup and recovery from on-prem to the cloud, what do we mean, right? So we mean that you're protecting on-prem resources, but you're doing it in ways that utilize Amazon resources, either in your account or in a managed account. In the case of DRUVA, for example, it's their account that it goes into, not yours. All of these partners are actually following our best practices, and so from a security perspective, from an efficiency perspective, we sort of shortlist them through what we call the APN competency program. Going to talk about some actual products now. So Backup Exec is sort of a mainstay of the SMB world. I think, by market share, I think it's got the largest for its segment. And that is not a typo. It is not Backup Exec 2.0. It is Backup Exec version 20 that supports deploying to AWS via its cloud connector. So you've got it on-prem, and this is, by the way, if you look at the profile for Backup Exec customers, the vast majority of them are not protecting even more than a terabyte. And so it's an inexpensive solution designed for folks who need very simple policies, very simple retention, very simple workflows. And when you are in traditional businesses, for example, and you don't have a lot of investment in IT, you need something that's not just going to be simple, but is actually going to work as well. And so VERITAS added support for backing up to AWS S3 in Backup Exec 20, and this helps customers that are on Backup Exec and traditionally we're using the tape model to move away from it. Now, if you're not quite on Backup Exec 20, you don't have to upgrade in order to still get your data into AWS. You can still use AWS Storage Gateway, a very, very reasonable solution in VTL mode. And you've been able to do that for a long time now. So if you think, well, I can't get started because I don't have Backup Exec 20, not true. You can get started today. All you got to do is download the AWS Storage Gateway, deploy it, and start using the virtual tape library mode of Backup Exec. We're going to talk about a customer. TRIMONO is they're a traditional business. I mean, they do recording and surveillance, sort of like DVR type deployments and manage that. And the way they used to back up the data was they had a person that they sent out, and they put the video on a USB attached disk, the kind that you would go buy at Best Buy or Fry's or something like that. Not a thumb drive necessarily, but a larger capacity disk. And then the guy would get back into the car, and they would go offload that and stick it somewhere. And in addition to that guy being very busy running around and all the things that can happen to the disk in the meanwhile, it's just slow. This is the kind of thing where most of the sites are going to have some sort of internet service provider, and if you have a solution that you're already using to back up the data, then chances are that workflow can fit into a turnkey solution that can talk to the cloud. So that's exactly what happened here. So TRIMONO adopted VERITAS Backup Exec for this use case, and they were able to not only reduce the recovery time from hours to minutes, but they were actually able to reduce the amount of time it took to get the data offsite and safe by a huge percentage, right? 86%. And so if you think about the improvement there, it's the difference between a guy driving somewhere and manually putting something on a disk and driving away versus simply uploading it. So there's no contest. And what I like about this customer reference is, this is a customer who, frankly, these sort of smaller businesses, they have fairly lean business models, and this is something that would directly impact the operating margin of the customer. So we're all, part of Amazon's customer obsession is helping other people's businesses run better too. The next one is NetBackup. So VERITAS NetBackup has a new version, 8.1, that was released last winter, and that added support for Glacier, but for our purposes, we'll talk about S3. So NetBackup's had S3 support for a while now. They've added a bunch of stuff. So what have they added? They've added the ability to store the data in S3 in a deduplicated format. They've added the ability for customers to use REST APIs in order to integrate NetBackup with their own automated processes. And they've added that lifecycle support. So when you say, okay, well, maybe previously I had it on a disk and then, I kept it for 30 days on site, and then for the next, 90 days of retention, I'm going to move it to a tape and ship it somewhere. Well, now you have the ability to upload it to S3, or if you want to, you can keep it, 30 days on disk and then move it to S3. And then, once it's been on S3 for a while, you can move it to S3IA. And then once it's been in S3IA for a while, you can move to Glacier. Previously, prior to 8.1, if you were to try to do a lifecycle migration, NetBackup would get very confused if you put it in Glacier. It wouldn't know how to handle that. Now it knows how to handle that. So that AWS specific integration, Glacier's integration, is unlike a lot of other cloud platforms integrations. Other platforms that have different tiering work differently, right? And so in Amazon, if you want to support S3 and Glacier, you have to specifically support S3 and Glacier. There's no way to build support for 19 different cloud platforms and support Glacier. You have to be in it for AWS customers. And so that's one of the reasons why we say, if you have NetBackup and you want to use Glacier, upgrade to 8.1. It works. HAGERTY, another sort of traditional business. So they are an insurer. And this is actually a reference for two solutions. The first one is NetBackup. So they used a combination of virtualized environment and application-oriented backups and sent both of them to the cloud. So for the virtualized environment, they were using Veeam, and for the application-specific stuff, they were using VERITAS NetBackup. And in both cases, they were using AWS Storage Gateway. For the Veeam solution, they were using File Gateway because Veeam doesn't know how to talk to S3 yet. So it used File Gateway as the intermediary. And then for VERITAS NetBackup, they used VTL because they wanted that simplicity of the VTL model and the ability to do one-click archival to Glacier. So this is a great customer use case because it includes the use of AWS Storage Gateway in multiple modes, I might add, which means that this customer is really getting their money's worth from AWS Storage Gateway. RUBRIK is a new player to the backup market, and when I say new, I mean not 20 years old. So they've come up fast in the all of the sort of market segments. They're definitely adding features at breakneck speed, and part of that features, those feature additions were supporting the cloud. So they support the cloud for if you have RUBRIK Brick, which is what their appliances are called. If you have RUBRIK Bricks on-prem and you're interested in keeping some amount of data on-prem, but not all of it, and you want to tier it off to AWS, you can definitely do that with RUBRIK. The second customer reference here is FUJIREBIO, and so what they are is a in vitro diagnostics company, and so they had many locations, and they sort of were trying to solve for the same problem of we want to get rid of our tapes, and so they chose to get rid of their old backup solution, replace it entirely with RUBRIK, and in the process, get rid of tapes as well, and move to S3. So another great customer reference. Next solution is COMMVAULT. COMMVAULT's been a launch partner with us for a long time now, going back to, gosh, at least 2015. They were a launch partner with S3 Infrequent Access. They were a launch partner with Snowball, and they've been a launch partner on a number of other features as well. And so what they're able to do, because they've been sort of cloud focused for a long time, is they've been able to build their workflows around not just enabling customers to do backups, but also you can then leverage those backups for other sorts of activities like disaster recovery. So we have two customer references here. The first one is PFD Foods, and so they're a Australia-based food services company. And what PFD wanted to do was they wanted to actually get verification of the and improve their auditability of their backups. And so that's a pretty common, I would say, pretty common ask. When you have a lot of assets that you're backing up, sometimes those reports get overlooked, and you need a way to actually very easily and simply audit your backup state to know, am I protected or am I not protected? It needs to be a very simple determination. So PFD relied on COMMVAULT for that, but in the process, they also got rid of tape, and they were able to reduce their costs and improve their flexibility. And then the next partner is DRUVA. They have, as I mentioned before, they have two products The one is Phoenix and one is INSYNC. Phoenix is the virtualized server backup solution and DR solution, and INSYNC is the more sort of customer facing, or I should say end user facing solution, where you can protect the data on your phones, on your tablets, on your laptops, on your desktops. But they both fundamentally work the same way, in the sense that they have clients that you deploy on end user systems, or a agentless deployment on the virtualized systems, and then they talk to AWS, storing 100% of the data there. Now they have caching appliances. Don't get me wrong. If you have 300 systems that you're trying to back up, you're not all going to necessarily, send the same data over the internet, right? You want to be able to be smart about this. So they have caching appliances that they can sort things out and do things like client ID dupe to make sure that they're only sending up one copy of the unique data, and then they sort out what are the different points in the catalog that need to reference that when it all gets up to AWS. So I think if you look at backup as something that you sort of like to wash your hands of, as some people do, and you want a solution that doesn't require you running any infrastructure, and if you look at the our Amazon Web Services, the whole point of us running services and not necessarily products is so that you get to run less infrastructure and you can focus on your core competencies. DRUVA is in line with that concept. So if you look at backup and recovery as a service, as something that goes all the way to maybe the right side of something being managed for you, but you still having control, then I would say you should spend some time doing an eval. The second customer reference for DRUVA is called TRC, and so they're also an engineering firm, and they actually noticed that since they had acquired a lot of companies in their growth mode, that they had the same similar problem. They've got people and equipment and multiple backup systems throughout the world, and none of them were giving them what they wanted. They wanted that ability to be super flexible. They wanted the data in the cloud so that if something happened to a site, everything would be okay, but they still wanted to be able to have their workflows that would give them auditability, that would give them the ability to grow individual sites without having to provision additional infrastructure. So they gave themselves like 45 days to make a decision and implement. And the folks at TRC, when they look back on their adoption of DRUVA, they said, our number one mistake was giving ourselves so much time. And I laugh about that because in the backup world, things traditionally don't move that fast. They're usually a lot slower. So if you think, well, I want to change my backup infrastructure, but I just don't have time to do it, the idea that you could do this in like a couple of weeks, get implemented and deploy and retire your old solution is just, it's radical. It's completely game changing. So if you need that flexibility, but you think that you don't have time or you don't have cycles to run a project like that, not having infrastructure to manage doesn't take that many cycles. This next one that we're going to talk about is called CLOUDBERRY Labs. So CLOUDBERRY is a sort of a household name in the cloud in the sense that a lot of people use it for personal backups, but they didn't really get a lot of business play until recently, and they've started having an MSP program, and they've got a more like commercially oriented product, but it's definitely for the lower end sort of cost element, and so that turns out to be great for things like municipalities. So this customer references EDGARTOWN, Massachusetts, and they didn't have that much data to back up. They only had 1.5 terabytes. They might think that it's a lot, but if you compare that to like some huge enterprise that's got petabytes or exabytes of backup data, it's nothing. In spite of that, municipalities are often overlooked. What are the things that municipalities store? It's important stuff like death records, birth records, marriage records, divorce records. You've got plans for things that are getting built. You've got inspection reports. You've got deeds. These are all things that make our world go round. We often forget about them, that there's some IT person somewhere who has to protect this data. And they may not have a lot of expertise, or they may not have a lot of cycles, or some municipalities may not even have an IT budget. It was meaningful for EDGARTOWN, Massachusetts to cut their costs by $800 per year. So what do you think their total budget was? It might not have been that big. And so I think that having a customer reference and calling out small businesses and municipalities as small businesses is super important, because the things that they're responsible for we often overlook. So if you have in your own town perhaps need for maybe SMB type backup, CloudBerry is a great low-cost solution that's very flexible and straightforward. And our last partner solution that we'll talk about is something that does one thing and does it well, and that's STORREDUCE. So STORREDUCE is a deduplication solution, and it has S3 on the front and S3 on the back. So what does that mean? Well, it sits in between purpose-built backup appliances, like it sits in between things with cloud connectors. And so what do I mean by that? I mean, let's say, for example, that you're using COMMVAULT or using NetBACKUP and you don't want to use their dedupe solution. Maybe it requires too much hardware. You can put STORREDUCE on the other side of that. You can point the cloud connector in NetBACKUP, for example, at STORREDUCE, which gets deployed as a virtual machine on-prem or in the cloud. Obviously, for reducing the amount of bits that you send over the wire, you would deploy it on-prem. And then STORREDUCE is going to do deduplication in the same way that like a data domain would do deduplication or Quantum DXI would do deduplication. And then it's going to pass that data on through to S3. And the reason that it's interesting is that A, it scales out horizontally. You could have dozens of nodes in your cluster. B, it gives you a whole lot of flexibility because now you've got all your data deduplicated, but it also gives you the ability to do things like snapshots and clones of data sets. You can clone a petabyte in like 7 seconds. It's all memory bandwidth type metadata operations. And because it stores all the metadata in S3, something horrible could happen to your on-prem cluster, and you just fire up a new cluster, point it at the S3 bucket, and it knows exactly where it was when it left off. So you can't say those things about the purpose-built backup appliances that it's replacing. But for customers who have a lot of data and they're concerned about the cost associated with either egress costs or storage costs, people who say, I like the idea of getting my backup data in the cloud, I like the flexibility they would give me, but I'm afraid of the financial element. STORREDUCE is something to check out. If you combine STORREDUCE with the cost of S3IA, you very frequently actually end up with more like Glacier pricing. So if you said to yourself at any point, I would love to send my backups to the cloud if only S3 was priced as Glacier was priced from a cost of gigabyte month perspective, STORREDUCE is something that can actually get you there. So that's a smaller company, they're not this huge company like VERITAS or COMMVAULT, but because they sort of do one thing and do it well, a lot of customers are finding value in deploying them. And then when they start deploying them in things like backups, they realize, oh, actually, I'd like to deploy them for all of my cloud storage needs. I've even heard of customers deploying them on-prem with on-prem object stores that folks are using in order to not have to buy additional capacity. So it's definitely follows the be a useful tool concept. So their customer reference here is Globe Telecom. Globe Telecom was looking to stop buying more data domains, frankly, and they're quite expensive appliances, and they were doing lift and shift from the old ones to the new ones. And so the idea was, if they could just stop spending money on that, they'd be able to spend money on other things that they thought were meaningful. So they implemented STORREDUCE. They started sending their data to the cloud. So sending the data to the cloud actually was something that they had previously ruled out because it was too expensive without good deduplication. They already knew what their deduplication ratio was going to be because they were using purpose-built backup appliances. And so when they implemented STORREDUCE, they were able to get exactly the same dedupe performance, but end up with the data in the cloud where they could keep it for their term, which was 10 years. So for you guys, the audience, I'd just like to suggest 3 things. The first thing is take a look at the thing that you're using today. If it's anything from TSM or Spectrum Protect or VERITAS NetBACKUP or Backup Exec, if it's COMMVAULT, if it's EMC Networker, all of these solutions can talk to the cloud today. And so either via VTL or via File Gateway or via their native cloud connector, depending on the version that you're on. If you're not sending your backups to the cloud today, ask yourself, what am I doing? Am I putting a tape in a truck where it can burn up? And then the second thing is, if you've not played with Snowball, it's so cost effective. I highly recommend that you check it out. You can experiment with that seeding process. Deploy storage gateway. Both of these are great ways to get data into the cloud. Once you integrate these things with your processes, you can sort of set it up and forget it. These are very low maintenance solutions. And then the last thing is, if you're thinking about choosing a new solution in the future, consider trying it out in the cloud first. There's no reason for you to wait for an appliance to get procured for some sort of try and buy agreement. Just use the AWS marketplace. You can oftentimes experiment with new solutions that you would have never even been able to afford or you didn't want to commit to on-prem. You can experiment with these solutions in the cloud for pennies or dollars. So if you are looking at changing your backup solution and you want to send your backups from on-prem to the cloud, AWS Marketplace is a great way to experiment and identify if these solutions are going to meet your needs. Thank you very much for your time today. I hope we learned a lot together, and good luck.